Testing, testing, 1, 2, 3. Testing, testing. Good. Good morning, Fancy Meat Computers. How's everybody doing today? I hope you all have had a good sleep last night and you're all ready for awesome, wonderful times in class today. Question, is it mandatory that the tutorial for Monday should be in person? Well, I'll speak to the rest of the tutorials for the class in general. So, the situation with the tutorials is that we had sent out that survey. A number of you filled it out. That we'd set up that survey to see how many people, how many sections of virtual tutorial we needed to accommodate the people who would not be able to attend in person this semester. And so we set up one tutorial section for virtual learning. Basically, if you can come to a campus, you are expected to come to campus for your tutorials. While there's nothing preventing you, technically speaking, from attending the virtual tutorials, if everybody gets lazy and doesn't come into campus because it's work to move yourself, then the virtual tutorial, the one section that we do have, gets full right up, which results in a less nice learning environment for everyone, including those people who can't make it to campus for whatever reason. So, you are expected to come to your in-person tutorials in the flesh. So that's my word on that. Isn't the tutorial on Tuesday? Well, there are, oh, yes! Yeah, let's take a look at the Piazza poll and see when we're going to be having that. The, should be settled by now, I think. Where is there it is. All right. So, let's see. So, the overwhelming majority, 28% of the class, our virtual section shall be Friday from 11:30 to 12:20. So there you go. Let me just make a quick note, or else I'll forget. There we go. Cool. So, so that's the deal with the tutorials. Yep, tutorials start up next week. So, a number of you have been having questions, comments, and concerns regarding Piazza and how one goes about doing stuff with Piazza. So, or not Piazza, Jupyter, pardon me. Mark whipped up a very, very nice video, which is a tutorial introduction to the Jupyter system. So, it's called The Beginner's Guide, Jupyter Hub. So I would recommend taking a look at that if you have any remaining outstanding questions about the Jupyter system. Yeah, Friday from 11:30 to 12:20, that will be the virtual section. Virtual office hours. Yes, I will commit to virtual office hours. We'll see how that goes. I might have them at the same time as my regular office hours. Have like people dropping in on the computer and people dropping in on in person. I think that might be a decent way of going about it. Were there any assignments this week? There were none this week. There were none this week. Yes, and we've got an endorsement of the video. What if you have a class during the virtual tutorial? Then you can pick it up later because it will be recorded. So if my schedule says that I am supposed to be in the Burke Science Building for that time and this course, what does that mean? That means that you have to be in the Burke Science Building at the specified time and in the specified room because that's where the tutorial will happen. Use a map. Oh, I think there's an app now that like gives you directions within the buildings. Yeah, you only have to attend one tutorial, not both. Please just, if you have been assigned to an in-person tutorial, go to that. Unless you're one of those people who said up front that you need a virtual section, in which case that's for you. Where will the tutorials be uploaded? Mark, I'll ask Mark to put them up on his YouTube channel. MacQuest, yes, that's it. Elliot, if we do the assignment 1 locally, submit it, download it from Avenue, submit it by by filling it out, you complete the assignment, and then uploading it back into the Avenue Dropbox, that's submitting it. Yes. So one thing that I will just say right now about these Jupyter things is that a lot of people, well, not a lot, but like not a lot as a percentage, but like a decent chunk of people have a difficulty where they think that simply by entering the answers, the computer system automatically takes that as a submission. That's not the case. You have to submit your assignment as well once you're finished with it from the same page that you fetched it from on Jupyter. So we've been having some issues, some difficulties with Jupyter. Yeah, we'll try to keep that as, constrained as possible, but there was some talk of some extreme measures to fix things. So we will try not to do anything that messes things up for people, but there's been some difficulty with the courses and the accounts on there. Cool. Lots of questions, geez. I tried deleting it, but it says that the directory needs to be empty before deleting the folder. How do you empty the directory? By deleting everything in the directory. Delete everything in the directory, and then you'll be able to delete the directory itself. You have 1 tutorial per week. My goodness, this is a lot of questions. So the tutorials for this class are... So we are opening a virtual section in addition to the in-person sections, and that section will be on Friday. Well, your in-person tutorial takes place at the same time as the virtual one. How will that work? Well, you'll go to one or the other of them. You don't go to both. You do not have 2 tutorials per week. Yeah. Yeah, like the virtual section is for people who live overseas or people who are, in British Columbia or something. Okay. All right, I'm going to continue with the lecture now. Cool. So, right. We were talking about algorithms. We were talking about how you write an algorithm. So, just to review, in order for an algorithm to be executed by a computer, in comparison to algorithms such as those encoded on recipe cards that are to be executed by a human being, algorithms need to have 2 properties. They need to be precise, that is, the next step must always be determined unambiguously from the previous step, and B, the algorithm must be effective. That is, it must be written in the language of the machine. So, going back to our earlier example of the x-intersect finding algorithm on the monotonically increasing function, here is a question. What happens if f at m is equal to 0 after instruction 2? Remember, so if you recall the algorithm, we've got a range, right? We calculate what the function is at the middle of that range, and then we move the bound in depending on whether it's higher or lower than 0, right? If f at m is exactly 0, then our midpoint just so happens to exactly fall on the point that we're looking for. But how would the algorithm deal with this? So, we have 3 options here. 1, the algorithm is not precise because it is ambiguous. 2, the algorithm is precise, ambiguous, but the input which leads to f at m equaling 0 are not allowed. Or 3, either instruction 3 or 4 as executed, it doesn't matter. So, this would normally be like an in-class, like raise your hands type thing, but that doesn't work quite so well here. So, although I suppose I could do a poll, couldn't I? Yeah, let's do a poll. So, poll question: which one? A. Oh my goodness. There we go. A, B, or C? So, we've got most people thinking it's A. And we've got a few other people thinking it's B and C. That actually works pretty well. Ah, C is making a comeback. We'll just, yeah. Some people must be sitting right on top of the server. I've got 144 viewers. Ah, there we go. 69 votes. A is still in the lead. C is at 35%. This seems to be a reasonably stable distribution. So, let me explain why, let me explain. So, first of all, let's deal with answer C at the moment. Well, it's A, B, and C, right? A, B, C in numerical order. Either instruction 3 or 4 is executed, it doesn't matter. Well, so you don't get to get out of the requirement of having a precise algorithm by saying it doesn't matter which statement gets executed, right? It does matter which statement gets executed because it matters how you close the interval, right? The best way of handling a situation like this would be to handle it explicitly. You would say, you would insert another condition. If f at m is equal to 0, then we have found the x-intercept, so we can stop computing. But that's not how this algorithm is arranged. The ambiguity that is being talked about in answer A, which most people selected, is likely this ambiguity between f at m being less than or equal to 0 or greater than or equal to 0. So you can't have both at the same time. They're not, they're overlapping, right? If f at m is 0, both of these things happen, except for one thing. This word otherwise, right? To say otherwise is to imply that this statement executes if this one doesn't. In fact, we could just say otherwise and leave this if out. This would be your classic if-else formulation in terms of an actual program. So while it looks like it's ambiguous, it's actually not, right? It's actually not ambiguous because these steps have been arranged in an order, and if executed in order, there's no ambiguity about whether step 3 or 4 executes, right? So the answer is actually B, surprising everybody, except the 19% of people who voted B. The algorithm is precise, but the inputs which lead to f at m equaling 0 are not allowed. I dislike how it states this. Basically, because we're working with a floating point algorithm here, you're not going to hit anything precisely. Probabilistically speaking, the probability that unless you very carefully arranged the function and the ranges so that you knew mathematically that the precise middle of that function or the precise middle of that range hit that thing, you would not be able to hit 0 exactly because of a thing called floating point error. It's kind of a technical point that we're going to revisit. Yeah, this is my wife's mug. I drink from her mug sometimes. We're going to revisit this issue when we come to talk about floating point numbers specifically. But yeah, there's basically, once you have a decimal number in a computer, you have to you have to get rid of the idea that you can represent numbers exactly. All right? You can do it if they're whole numbers. Whole numbers have, precise precision, so to speak. But if you have decimal numbers or scientific notation, numbers in scientific notation, inside of a computer, it's impossible to get exact precision most of the time. At least you shouldn't assume that you're able to. So that's why this is, yeah. There you go. Yeah. Only way m is equal to 0 is when a minus b is 0, but that isn't possible since b minus a is greater than epsilon. Yes, that's another way of, yeah. Another mathematical way. So, is the output of this algorithm always unique? Let's see. What do you think? I want to do a poll. Where did my poll go? Ah, there we go. Poll! There we go. Unique? Yes, no. No. Maybe. What does unique mean in this context? That's the intelligent response. Ha. So, the correct answer here, which most people have got, is no. 49% with 87 people reporting. So, the output of an algorithm should, like, there are situations in which the output of an algorithm should not be unique. If you have an algorithm and you give it the same input twice, it should produce the same output twice. That's how, otherwise, what's the point of the algorithm? If the algorithm is unambiguously specified, then if you give it the same inputs, it will produce the same outputs every time. If this property did not hold of algorithms, there would be no way we could, write software to mark your assignments. So, the output of this algorithm is not always unique. If it's given the same inputs, it'll produce the same outputs because, as we established, it's deterministic. Yes, it's unambiguous. Yeah, determinism, deterministic. That's another good word that just came up in the chat. Why can't you just add another condition? Yeah, no, I already, yeah, that would be my preferred solution to this problem, actually. Yeah, so good. Good. End that poll. So we're talking about algorithms. Let's talk about a few more. Let's talk about a few more properties of algorithms to sort of whet our appetites. When we talk about algorithms, generally speaking, we are interested in correctness and efficiency. These are the two, aside from the conditions which allow the algorithm to exist in the first place, that is, that it's precise and that it's effective, the next things that we're worried about are, is it correct and is it efficient? And how is it efficient or inefficient? So correctness, we're going to get into correctness, the concept of correctness, more closely when we get into topic 6, which has to do with correctness and testing. But in general, this is what correctness means for a computer algorithm, and this is the standard to which your assignment solutions will be graded. For a given input, are you producing the expected output? So, we have our algorithm. If we feed it these sets of inputs, do we get this output, right? It's the way that we determine the expected or intended output. It can be in any number of ways. It could be we've used a different computer algorithm to generate it. It could be we know something about the situation, and that provides our knowledge of the output. It could be that we have test cases. It could be that we have been given actual, literal input and output, and we just have to fill in the gap with an algorithm. In general, with the programs that you will be expected to write on your exam and on your tests and on your assignments, you will be given correctness conditions two ways. Number one, you will be given a problem description. So, it'll be a word problem. It will describe what the input should look like and how the output should relate to it in, words. And you will be given test cases. The test cases are actual, literal inputs and outputs, and it is your objective to get those test cases to pass. The test cases that we give you are different from the ones we use to grade your assessment, grade your solution. So, this is often a thing I hear from students. It's like, oh, well, if I get all of the visible test cases, that should be good enough. I should get 100% on the assignment. And it's like, that's not actually how software works. It is actually totally possible to write an algorithm for any particular test case without having to actually do any work. Let me demonstrate. Get it. Topic 1. Yeah. So let's just say, for the sake of interest, let me just... Boop-a-doop, boop. No, I'm in latex mode. There we go. So this character toggles whether or not a line of code will actually be executed. It's called a comment. So let's say I had a test case. Let's say it was like, function, let's call it, F. Let's test F1. So F1, if we give it the value of 6, 6 squared is 36, minus 4 is 32, we want it to equal 32, right? Very simple test case. Let's see if it happens. Python 3, topic 1. Maybe I should print this. That would help. True. So that's true. That tests that test is correct, right? However, you don't actually have to implement the function in order to meet that test case. All you have to do is say, if x is equal to 6, return 32, right? As long as I get my syntax correct. Jeez. True, right? So this version actually implements the function, right? This works for values of x that aren't just the one we're expecting. This version only works for the input that we're expecting. So, like, if I were to print, f1 at 5, is equal to 25 minus 4, 21. Right? That's another test case. If we run this again, in this configuration, this second test case doesn't pass, right? Because we didn't know that test case was coming, so we didn't write an if statement for it, right? So that's why when we do the assignments, we hide some of these test cases from you. So, because if we just gave you all of the test cases, then you could just write an algorithm specifically for those test cases. You wouldn't even have to, all you would have to do is, this goes here, this goes there, I know how to code. And it's like, no, you don't know how to code. You know how to rig the system. So, yeah, in order to actually program correctly, you need to be given, we need to test you against test cases that you can't see, that you're not expecting. So there you go. That's why that works that way. yeah, you could just hard code the test cases, and that would, that would technically pass, but you wouldn't learn anything, So let's talk about efficiency. How long does it take to produce the output for a particular input? So we're talking about, when we're talking about efficiency with computer algorithms, there are a few different things we can talk about. We can talk about time efficiency, and we can talk about space efficiency. We can also talk about what's the efficiency in the worst possible case, what's the efficiency in the best possible case, what's the efficiency on average. We'll get into ideas of efficiency and what makes an algorithm efficient later on in the course, but just be aware that it matters. It matters how efficient your algorithms are. If your algorithm is improperly constructed, it can be correct, but impossible to execute. How many resources? Yes, and so, yeah, space efficiency generally means memory efficiency. How much memory are you using? So, if for the assignments, if it doesn't necessarily mean that you will get 100% on the question if you pass all the given test cases. Yes, that is precisely the point I was trying to make it. Yes. So you made a double equal sign, you made a Boolean instead of equating the value to 32. Yeah, so I guess I'll explain the syntax here. Double equals is this thing equal to that thing, right? Is the evaluation of F1 equal to 32? It's test for equality. All my homies hate big O to the n factorial efficiency. Oof! Yes. Terrible. There you go. Yeah, some of you guys know what you're talking about already. Though if you don't worry about it. If you don't know what Big O is, we're going to talk about it a little bit in this course, but it's really something, like Big O is really something that you will be talking about when you take a proper algorithms course. This is really, like, this is intro programming, right? So all you smarty pants who know, like, second year material already, don't worry, eventually we'll find something challenging for you. That you can take 3MI3 and then I'll blast your pants off with math. Yeah. Anyway, so here's a question. Can you take the exact x-intersect by setting epsilon equal to 0? No, I don't want to add an option. There we go. Yeah. No, you're not expected to know Python already. We are going to teach Python. We are teaching Python in the course. This is Intro to Programming, where you're not expected to know Python coming in, and you will know Python going out. That is the purpose of this course. It's just, this is like, for all of you people who are not in Comp Sci, you have had the misfortune, perhaps misfortune, in one sense misfortune, in another sense great fortune, of taking this class with the comps, like the regular Comp Sci stream. So that means that, like, about 100 of your colleagues probably know Python already quite well, and know a lot about programming already because they've chosen to major in Comp Sci. Why would you choose to major in Comp Sci if you knew nothing about computers? Maybe because you're interested in it. But anyway, yeah, don't worry. Don't let these guys scare you with their technical knowledge. They're, you will know it all too. And don't worry, they'll run out of tricks. They'll run run out of tricks sooner or later. Like when they hit my third year class. Anyway, so can you? No, that's correct, and it's for the same reason. It's also to do with that. So it's actually I'll yeah, brute force go. So have you guys ever heard of Zeno's paradox? So back in the days of the ancient Greeks, Zeno's paradox is if I take an arrow and it halves the distance, if I shoot an arrow at you and it halves the distance between me and you every second, it will never actually reach you, right? This is the same thing but with computers. In Zeno's paradox, Zeno's paradox is fundamentally flawed because arrows don't behave that way. But in this case, computers and math actually do behave that way. So what we're doing is we're taking an interval and we're, reducing it by half each time. And through subsequent divisions by 2, you can never reach 0. And in order to stop the algorithm, you would have to reach 0 because we've set epsilon equal to 0. So there you go. So there you go. Bump. The technical. So you can So eventually you'll hit floating point error with this. So let's talk flowcharts. So for all of you people who have never programmed before, this is kind of the point at which you should really start paying attention. Because I am now... Oh, Zeno's paradox as Achilles racing a turtle. Oh, well, I'm sure it has many forms. Yeah, it would be an infinite loop. Yes. That would... the condition in the previous page would result in an infinite loop. Correct. So, algorithms as flowcharts. So, when you are learning... when you're learning to program for the first time, this is a method of abstraction that you may find useful to help you design algorithms on paper. So one of the ways you can learn programming from bare bones nothing, like some of you are, is to do it on paper as a flowchart and then translate that flowchart into programming code. So let's learn how to use flowcharts. So in a program, we have instructions, and we have conditions, and we have a few other things as well. But let's talk about instructions and conditions for the time being. So, an instruction is something like a statement, a command, or an action. Things like turn green light on, continue straight ahead, subtract V from U. So, conditions are things like the drum is full, the water boils, or U is not equal to V. So, pulling up our program that we were doing, something like M is equal to A plus B divided by 2, that is a statement. That, in flowchart land, ho-ho, side-by-side action. These guys here, every one of these guys, is one of these types of boxes. The control goes into it, it does something, control goes out of it. This here is an if statement. If statements are conditional statements. You have a condition here, and depending on whether or not this statement of mathematics is true, you will either exercise this branch or that branch. In the flowchart world, the way that we write that is we have a diamond with the condition in the middle. If that condition is true, if you say yes, then you go down one branch. If you say no, you go down the other. All right? It's at this point that I wish I had my chalkboard. But anyway, so that's how these elements work in terms of flowcharts. So, in general, with flowcharts, we have basic instructions, which are like these. We can chain together basic instructions, right? A basic instruction can lead to another basic instruction. We pronounce this S then T, and sometimes we'll have dots at the beginnings and ends of algorithms to indicate where they start and stop. Okay. Now, here, it's kind of funny, but if you get the stuff on this page, as well as, if you get the stuff on this page, you can program. Like, honestly, and this is actually true. Like, this is technically and mathematically true. If you understand if statements and you understand loops, thank you. Yeah, that's Felix. He's our 5 months old. He's probably hungry. Normally he's hungry. Babies are interesting. They only have 3 modes. They have hungry, playing, and sleeping. And like they go through these on like a 2.5 hour cycle. But anyway, so if you understand these 3 ideas, then you know everything there is to know about programming, almost. It basically, all programs are composed only of these constructs. Tiny meat computers. Yeah. So, can we get a baby reveal? Maybe. We'll see. If I hit 1,000 subs, maybe. So, we've already explained, we've already talked about if statements. During your program flow, if your program hits a condition and you can select one or the other way to go, that's called an if statement. Again, this is an if statement right here. You can write an if statement like, if x is not equal to y, got insert on there, then, print something, otherwise print something else. So that's a conditional statement. When will we start teaching Python to the child? Well, I gotta teach him English first. So, hunger is temperate, yeah. Is that oh, it's actually a rug. But yeah. Yeah. So, what am I talking about? Yes, if statements. So, basically, you've got 2 styles of if statement, right? If you eliminate the else case and just have, if x is not equal to y, do something, that's this guy, right? And the way that looks in the flowchart is you take the no branch and you just pair that back up with the flow after the statement, right? So, if it's yes, you execute the statement, you keep going on. If it's no, you skip the statement, and then you just keep going on. Just teach him binary. Yeah. Oh my gosh. Yes, I hope that the baby ends up to be modular and extensible. So if you have something on the no branch, that's an if-then-else statement, which is that's the form that this if statement originally took. If you have an else statement, then it's if-then-else, and you've got things to do on both the yes and the no branch. No, his name is Felix, which is actually pretty close to how that would be pronounced, I guess. The name of Elon Musk's baby. But all right, so that's one. The other concept that is absolutely crucial is while loops, or loops in general. So you need conditions and you need repetition, and from conditions, repetition, and statements, you can construct every program that has ever been written. Literally. Like, these are the fundamental building blocks. It's like the whole universe is made out of atoms. Every program is made out of statements, conditionals, and loops. Can't imagine. Baby replying in binary. I'm not fluent in binary, so that would be stupid to train my child to be fluent in a language I'm not fluent in. Yeah. So, anyway. So, loops, then. I'm using a loop, actually, right here. So loops are similar to if statements in that they also use conditions, right? So this guy right here, that's the condition. B minus A is greater than epsilon. Condition. While B minus A is less than epsilon, perform the following statements, right? So what you do, how that looks in flowchart land. Yeah. Oh my gosh. How that looks in flowchart land is you have your condition, but rather than the control just ending and going on after the statement on the yes branch, the control actually returns to above the condition. So, if it's yes, the statement executes, and the condition is reevaluated. So long as the condition is being evaluated true, you're stuck in this loop. If only once the condition comes out negatively, you come out of the loop and continue on with the program. So, for example, in this guy, while B minus A is less than epsilon, we continue doing all of these things. This process will gradually narrow down the interval, narrow it down, until this condition no longer holds, in which case we return, that is, we set as the output A plus B divide by 2. We'll talk about return statements and how a function works a little bit later on. So this while loop does a thing for a period of time until the condition comes out false, and then it does something else. Control flows past. He wants to learn Java. No, he can't have Java until he's old enough to handle the caffeine. A C# baby. Oh. Why would you? Yeah, that's true. Yeah. It's like I mentioned I have an infant child, and like it's not like the chat can talk about nothing else during literally the most important section of this entire course. Hilarious. But anyway. Yeah. Oh yeah. If you C# things around a baby, you should take them away, because babies can't have C# things. Ha! Oh, man. You should have known me before I had a kid, because I was definitely king of the dad jokes already. So, while loops. They repeat statements until the condition comes out false. So, one of the things that was alluded to by one of your colleagues in the chat earlier, if this condition never comes out false, then you're literally stuck in this loop forever. The computer can't escape it. So it is absolutely 100% possible to break a computer with like 2 lines of code in Python. If you just say, while true, pass, you have locked the computer. You have locked the computer. You would have to like do a Control-Alt-Delete to terminate the program, because these 2 statements will that'll kill the program. It'll be stuck here forever, because true can never be false, and pass does nothing. So it's like do nothing forever and never escape. This is computer prison. This is computer hell. I have shown you computer hell. You want me to execute it? You want me to okay, I'll execute it. I'll do it. For you guys, I'll do it. Oh, this will cause an error, though. Let's say x is equal to 1, y is equal to 2. There, all right. Y is equal to 2. All right, here we go. Python 3, topic 1. Oh, true is not defined. But I guess I have to use a capital. I should have known when the syntax wasn't highlighted. There we go. All right, this should work. Actually, you know what? I'm gonna do you one better. I'm gonna have it scream. I'm gonna have the computer scream eternally in its hell. Print. End is equal to empty. There we go. This computer shall now scream forever. There you go. Don't do it, you have a family. Yeah, it's okay. Fortunately, this is command line, so I know how to send the termination signal. It's just Control-C, and that's the keyboard interrupt. But you can see how I had trapped the computer in computer hell. Pass is a blank function that you can put in to maintain syntax you need to the next line after a while or an if statement. So basically in Python, this is a technical point. In order for something to be inside of a loop, it needs to be indented 1 line. So if you leave it, like, you can't just leave it blank like you would in some languages where you could just do like open close curly braces. You have to actually put something in there. So pass is like, just don't do anything. I just want to hold that place open so I can come back to it later. But yeah. Yep. Okay, so that's time. I will answer questions / hang out with the chat for a certain amount of time. Yeah. This is class. You may disconnect the stream now, if you wish. Sounds of a newborn baby. Does computer have a limit to what it can handle? Yes, of course. You're limited by the amount of memory that you have and the amount of time you have to process things. What is the point of pass? It's primarily to maintain syntactic correctness. I'll give you an example. So, for example, if I tried the previous thing with just while true, with nothing afterwards, let me show you what happens. gives us a syntax error, unexpected end of file while parsing. It's like, that's not valid. So if you put pass in there, it makes it valid, and it's now doing nothing forever. So it's a way of making correct syntax. Where's my cat? Which cat? I have 2 cats. Yeah. What does end equal empty do? So in Python, in print, there are a bunch of like hidden options that you can do. End just disables print inserting a new line at the end of every time you do print. So that's how I could get a. Otherwise, it would just be on like new lines. A. But yeah. If it's infinite recursion, then stack memory is what limits it. Yes. Or in Python, your recursion is capped at 5,000 recursive calls anyway. Comments should have the functionality of pass. Then you should write a programming language in which that's true. Oop, I've got some real questions. You're welcome. If you have to do a flowchart, you will fail. If you already know you don't need to do the flowcharts if you already know how to program. Even if you don't know Python, you should be able to port like knowledge from Java or VB or if you've programmed in any language before, you probably can skip the flowchart step. The flowchart step is primarily for people who are still figuring out the semantics of programming in general. Cat reveal. Let's see. What's my current subscriber count at? Do the cats like the baby? Yeah, when he's not grabbing their fur. In the case of an infinite loop, does the computer throw an exception at some point to terminate the program? No. No, it doesn't. It depends on what language you're in. Some languages have like extra bits that detect for infinite loop, like they have infinite loop detection, but a lot of languages just don't. Not creating infinite loops is generally the responsibility of the programmer. Will we continue with these slides our next lecture? We will always continue the slides at the next lecture. I will never leave you to read the slides on your own. That's not how I roll. Can't you just... Is there any homework we should do for the next class? No, not particularly. Just have a nice weekend. Oh, it might be 1,000. I thought it was 5,000. There is a limit to it, though. Why keyboard interruption can stop the while loop? Because while the program is caught, it's only one process within the operating system in general, right? So way back, like if you're talking in the 80s, while an infinite loop would crash your computer completely and you'd have to do a hard reset. But because we're in an operating system that, has control over the processes, you can send signals to a program to tell it to terminate itself. Basically, I was just doing with command line what you would do with like Control-Shift-Escape in Windows, terminating a hanging program. Any language that quote-unquote solves the halting problem isn't Turing complete. I will post the links when I make the videos. I have to like make all of them manually each week. There's no like I wish I could just like write a script to have like YouTube generate all of my lecture live streams, but I have to do it by hand. So don't worry. The lecture link will be posted before the lecture. Can you submit on Avenue using Anaconda? Can you also do this for the tests and the exams? Yes and yes. Any readings? There are readings posted if you want, so go for it. Unlimited submissions? Yes. Are you able to do A1 with the knowledge so far? I would say no, but A1 is, I think, not. Might be. Check the syllabus to see where the due date is. I'm doing 3 courses this semester, and it's like, gosh, try to keep straight due dates for 3 courses. I tell you, they're like, but I'm doing 5. It's like, yeah, fine. No, the readings are just background. The readings are just background. You should be able to program with just what I'm doing in this course. But, you know, it's good background knowledge. Like, really good like, the readings are recommended but not essential, I guess is what I'm trying to say. What is assignment 1 all about? Basically, expressions. So, the topic 2 material. If you look at topic 2, like slide set 2, that's what A1 is based on. Yeah. So, if you use Jupyter Hub, you can submit through Jupyter Hub, and if you use local Jupyter, you can submit through Avenue. Yes, you can actually upload it to Jupyter Hub and submit it there as well, but normally people use Avenue because they can't get onto Jupyter Hub because they can't get a good VPN connection or something like that. So if you want to, you can do that, yeah. It's up to you. Can I add you on LinkedIn, sir? I don't actually have LinkedIn. Now that the console wars are over. Yeah, Nintendo won. Ha! I just proved that the console wars aren't over. When will you learn about terminals? In Computer Science 1XC3. Which I also teach next semester. So, we'll learn it next semester. Learning about terminals and learning about Unix and Linux and all of that fun stuff. I actually really like 1XC3. I taught it for the first time over the summer, and like that's just a fun course. I like it. Where are the assignments listed? They are not. They will be on Avenue, not Piazza. Piazza is just Q&A. We won't actually post any content there. Even though Piazza likes to think it's capable of that, it isn't. Do you need to switch to Linux for 1XC3? No, but you will need a bash prompt. So if you're not running Linux or Mac already, either Windows subsystem for Linux or emulate, like get a virtual machine up and running. Yeah, if you have a Mac, that should be fine. Yeah. 1XC3 sounds pretty daunting. Yeah. Yeah. It's like, this is what I did, right? This is what I did with 1XC3. I created the course that I wish I had had when I was your age and in your position. How do you get a Linux computer? Ooh, that's, you just, you have to flash a USB drive with a Linux image, and then you put that USB drive into your computer as it's booting, and you'll have the option to boot into Linux, and then you can install Linux to your computer from that USB drive. Arch, yeah. Am I going to teach 1XC3 this winter? Most probably. So I'm a sessional professor, which means that I work on, like, 4-month contracts, right? So, generally speaking, like, I'm a known quantity in the department, so, normally, like, they've never not given me a course that I've taught before that's been up for sessional. So the question really is, are there any new hires that are... Oop. Oop. Yeah. Yeah. So, like, the question is, are there any other professors who are, like, full-time permanent who are going to take 1xc3? And, I haven't heard any rumblings about it. So, there you go. Can you dual boot your computer with Linux and Windows? Yeah, I've run dual boot systems in the past. Yeah, absolutely, you can dual boot. I would recommend doing it on a fresh laptop, though, because in order to dual boot your system, you have to basically cut your hard drive in half and dedicate half of it to your new Linux operating system. Although, like, realistically, you probably only need like 50 to 100 gigs. Like, as long as you're not doing like huge, like, Linux is really lightweight in comparison to Windows, but oh. Maybe we can do lunch on Thursday when I'm into the university, eh? Yeah. Yeah, if you want to install Linux, highly recommend something like Ubuntu or Mint, because this they're like user friendly, and there's actually a base of users who are happy to help people. The general philosophy of Linux is read the manual. So, you know, some of the harder distros to work with, like Arch and Gentoo, it's like read the manual. You know, you don't need 2 drives to install Linux. You can partition your one drive so that it looks like 2 drives. Yeah, you can create a Linux partition. But the thing about creating a new partition on your hard drive is that, like, your Windows operating system will be using it to store data. So if you just go in and partition it, all of the data that's in the space that you're partitioning, will be destroyed. So I generally recommend, if you're going to set up a dual boot system, do it with a fresh PC that you've put literally nothing on. And then, you know, you can partition that drive and not have to worry too much about it. Yeah, so, why not go for Linux subsystem? Like, Linux subsystem is also an option, sure. But, like, you'll learn more from running Linux natively. And if the point of being in school is to learn things, you'll learn more this way. What makes Linux better? Yeah. What makes Linux better than Windows? How long you got? So, so apparently that tutorial section, the virtual one and the in-person one, are at the same time. As long as it's not the TA teaching both of them, that's fine by me. They can be at the same time, because you're not expected to attend both of them. Yeah. Yeah, no, like, you will learn a hell of a lot from running something like Arch, but running something like Mint is much easier if you're at a beginner level. Anyway, I'm gonna go. I've been chatting with you guys for a little bit now, and I got work to do, so. Yeah, a virtual machine would also be good enough. Yeah. Like, as long as you've got a bash prompt. We also have a Pascal server that you can log into remotely for 1xc3 if you want. Okay. All right. Take her easy, folks. Don't do anything I wouldn't do. Bye-bye.